Hi there, everyone, and welcome to another episode of Espresso 4.0. Today, we have a very special guest who needs no introduction. We will introduce him anyway. It is number one on analytical list of influencers on LinkedIn, number one influencer industry 4.0 on LinkedIn in general, and most recently, Manufacturing Digital Magazine announced top 10 global manufacturing influencers, and he got, no surprisingly, spot number one. You all know him. He is the king of Industry 4.0, the prince of digitalization, and the duke of IoT, all the way from the Windy City, Jeff Winter. Jeff, welcome, and thank you for grabbing a cup of coffee with me.
Thanks for having me here. And that's probably the funniest introduction I've had so far.
We try to keep it vibrant here over at Espresso 4.0. Thanks again for joining us, or me rather, over a cup of coffee. I think it's morning over there. Perfect time for coffee. It's middle of the afternoon for me. Also another perfect time for coffee if ever there was a wrong one. Why don't you start us off and tell us, what do you do actually?
So I recently started a new role as Vice President of Business Strategy for Critical Manufacturing, which is a MES software company. And what I do is I ultimately guide the company on the direction to be a best-in-class Industry 4.0 solution provider. And so that's really why I'm so involved in the industry and so many associations, academic groups, advisory boards, so that I can learn what's happening in the industry and use those insights to better guide my company.
Excellent. Okay. Well, I know that that a lot of us had that burning question because we see you everywhere. We just wanted to understand where you're coming from. Okay. I won't coddle you because you've been at this game for a while now. So I'm just gonna drop you in with a cold shower question. Is Industry 4.0 a scam? Is it just a marketing ploy, or is there some substance to it? And if there is, what is that?
Well, I can say no one has ever asked me this question before. So here's how I'm going to try and answer it. Imagine stepping back in a time machine and going back in time to the early days of just the first industrial revolution. If you were just to go up to a local mill worker in the 1770s, where the steam engine was just kind of really starting to take hold, and you were to ask them, hey, do you think this steam engine is going to be a revolutionary leap? They're probably going to scratch their heads, just completely unaware that they're standing at this dawn of an era that will stretch for decades, but ultimately change everything about their industry. Now, if you fast forward to today's discussion about Industry 4.0, just as it took time for the steam engine's impact to be fully realized, Industry 4.0's revolutionary changes based on technologies like artificial intelligence, IoT, digital twins, advanced robotics, and just all the other cool technologies, they're still unfolding. So we might not see the dramatic changes that a single invention like the steam engine presented, but we're definitely in the midst of a transformation that's integrating the digital world with the physical world. And once again, it will change everything: how we work, how we provide value, how we capture value, and even how we buy and consume stuff. Now, it's true, the term Industry 4.0 has been around for over a decade now, and some may see it as more of a buzzword than a revolution. However, just like the roughly 80-year span of the first industrial revolution from 1760 to 1840, at least according to National Geographic, these things take time. So the technologies defining Industry 4.0 are increasingly becoming integral to how industries operate, showing that while it's a slow burn, it's by no means just smoke. So no, Industry 4.0 isn't a scam. It's just playing a longer, more sophisticated game that requires a bit more patience to appreciate fully. You know, after all, it's a revolution in the way the whole world works. Now, one notable aspect that distinguishes Industry 4.0 from previous industrial revolutions is its strategic institutionalization. And it was mainly spearheaded by Germany. In 2011, as part of their high-tech strategy 2020, Germany introduced the world to the term and the concept that we know as Industry 4.0. And since then, it's taken hold all around the world, causing dozens of governments to make similar declarations and investments. And this means that the revolution isn't just driven only by technological breakthroughs, but also a concerted governmental just kind of force or forces by governments. So while the term may have been catalyzed in part by policy and economic interests, making it seem like a constructed concept, the resultant focus and investment in technologies to advance manufacturing are very real and are progressively reshaping our entire industrial landscape.
All right, fair enough. Amen. What do you have to say to some more hardened veterans from personal experience? Talking to some more seasoned process engineers, I've encountered people saying, in my time, we used to call that statistics. Nowadays, youngins call it machine learning and AI. What do you say about that? Is there a fundamental misunderstanding? Are they related? How would you answer that to someone who is not a data scientist?
So, indeed, the roots of machine learning are firmly planted in statistical theory, and both machine learning and statistics work with data to solve problems, which may lead to some viewing them as more or less the same. And yes, quite a few people, especially people with an exposure to statistics, but not statisticians, people like engineers, are the ones who mostly get it confused, in my opinion, because they know enough to be dangerous or just wrong. So statistics is primarily concerned with inference, which involves drawing conclusions about populations based off sample data. Machine learning, at least supervised learning to be clear, has a focus more on prediction. So it involves training a model on labeled data sets where the correct output is actually known. And the goal here is to learn a mapping from inputs to outputs to make predictions on new unseen data. So this type of machine learning is the one that is often confused with statistics. And many of the supervised machine learning techniques are drawn from statistics. If you look at linear regression or logistic regression, just two examples, but they pull from other disciplines like calculus and linear algebra and just computer science. However, other types of machine learning, such as unsupervised learning, often aren't as confused because it doesn't really focus on prediction in the traditional sense. It aims to discover patterns and groupings or structures without predefined labels or outcomes. Interestingly enough, though, the abstraction of machine learning from statistics with the use of libraries is often why some individuals make the argument that knowledge of statistics is not actually even that necessary to do machine learning. So they're actually starting to diverge more with time instead of converging, at least in terms of the confusion between the two. So let's give a manufacturing example of the difference here. So let's say you have a manufacturing company produces electronic components, and the company has a goal to reduce the rate of defects or defective products and improve overall production quality. So the statistical approach is to understand the factors that contribute to defects in the manufacturing process. So they will, use statistical models like logistic regression to look for the significant factors that increase the likelihood of defects. Now, with machine learning, the objective is to predict whether a new batch of products will be defective or not based off similar or historical data. And here they might use a decision tree classifier or more complex models like random forest or neural networks if the relationships are very nonlinear or involve interactions. And here the model can predict in real time defects from production lines. Now remember, that example was chosen where machine learning and statistics could more likely be confused. If we were a total different type of machine learning like deep reinforcement learning, there should be less confusion because it's fundamentally different from statistical methods.
Yeah, perfect. Thanks for the practical example. I think a lot of people can understand it better. It might even resonate with them much better that way. What, apart from what we just mentioned so far, misunderstanding between statistics and data science, and what would you say are some more common objections to Industry 4.0, and how valid do you think these concerns are?
So I would say just across the board, everyone knows that Industry 4.0 isn't just knocking on the door. It's kind of halfway through the entryway. So the discussions in boardrooms and just even in break rooms aren't about if it will impact the workplace, but about the urgency and the timing. Do we dive in head first? Do we just dip our toes and slowly go in? So it's not about if we should adapt to Industry 4.0. It's really about when does it make sense for your company. So Industry 4.0, it's a big deal, which also means it's expensive. And it isn't just expensive, it's also transformative. I mean, if it's done right, it fundamentally changes the entire company, every department, and nearly every single person's job. Now, the value, the benefit, and the reasons why people do it for this transformative power is also the biggest reason why companies don't or are hesitant, because transformative to a lot of people means disruptive. Now, what is interesting is I just read a study actually fairly recently that was done in 2023 by Sanuga, I believe that's how you pronounce it. Sanuga University aimed to explore the motivations behind the adoption of Industry 4.0 technologies among manufacturing firms in developing economies. You know, are they technology pushed? Are they market pulled? Or just government driven? And they analyzed something like 215 firms and found that adoption is not predominantly driven by the inherent technological advantages alone. So the technology pushed, which are not significantly related to adoption decisions. Instead, the findings actually underscore that market pulled forces such as competitive pressures and government-driven initiatives such as supportive policies and incentives play a more crucial role in influencing firms to adopt Industry 4.0 technologies. Now, if we look at barriers, I have two different answers for you. So one is, according to Rockwell Automation's 2024 State of Smart Manufacturing report, which is a survey-based report, the top reason is cost. And the second is skill set to implement. And the third is lack of skill set to optimize. And the fourth is employee resistant to change. So 3 of the top 4 have to do with people. And in the manufacturing industry, especially in the United States, there's a shortage of people. I mean, Deloitte this year predicts that the US alone, I think they did this along with the Manufacturing Institute. They basically said that we're going to need to create as many as 3.8 million new workers by 2033. Like we're going to need that many more workers. And roughly 1.9 million of these could go unfilled if current labor gaps remain unsolved. Now, the second one I was going to mention here is there was a study done by Helion in December of 2023, where researchers prioritized barriers to Industry 4.0 adoption through the application of something called total imperative structural modeling, and it's based off literature review. And at the heart of this study, they had 10 major barriers to Industry 4.0 implementation that they identified, ranging from IT infrastructure to training deficiencies. Yet when the dust settled, it became unmistakably clear that commitment from the top echelons of management wasn't just another barrier. It was the barrier which all other challenges stemmed from. And this finding underlines a critical truth. The success of Industry 4.0 hinges not on the sophistication of technologies alone, but on the strategic alignment and visionary leadership at the top. And I would argue this answer supports why people fill out cost as the top barrier from the Rockwell report.
Yeah, it's also interesting that kind of they're both saying to an extent that it's people that are the barrier, whether it's at the top or whether it's skill set necessary sort of in the middle management, if you will. Now, how can companies understand the impact of AI when it comes to process optimization and outside of just sales and marketing and demand predictions and stuff like that?
So oversimplified, I like to explain it this way. You can either think of AI as a tool to either augment or to automate decision making. So in areas like demand forecasting and predictive maintenance, AI supplements human judgment with data-driven insights, enhancing their decision accuracy. However, in process optimization, AI's role can expand to automating decisions entirely. You're basically letting AI take the wheel, and the AI actively manages and adjusts processes, analyzing in real time to optimize production and reduce inefficiencies and improve overall operational effectiveness. So this shift from augmenting to automating marks a significant transformation in how companies leverage AI to achieve greater precision and efficiency in their operations. But be clear, I'm not saying that everything needs to move to automated decision making. You need to understand the balance of when you want to use AI to help you make a decision and when it's better to have AI automate a decision for you.
Indeed, fair enough. And now that we've covered that, can AI really scale in manufacturing, or is it just another buzzword?
Well, can it scale? Yes. Is it easy? Absolutely not. Actually, it's quite hard. And I would have to say there are four major things that make AI more unique and challenging to scale than, let's say, other technologies out there. The first is talent. Simply put, it's hard to find AI talent. There's often a shortage of skilled personnel who understand both AI and manufacturing processes deeply enough to implement and scale AI solutions effectively. And typically, AI isn't something you could just pick up in a week-long training course. It requires potentially years of training to be good. The second is data. AI can't work without data, and oftentimes it needs a lot of it. And unlike IoT and digital twins and other technologies which could process real-time data, AI often needs historical data to be super effective. And with that, manufacturing processes generate vast amounts of data, but it's often noisy and unstructured. So ensuring this data is clean and well organized and useful for training AI models, it's a significant hurdle. The third is explainability. So AI models can often be easily explained by themselves, the model, but individual answers produced by the AI models can be quite difficult to explain. And in manufacturing, especially where safety and even precision are paramount, this black box nature of many AI systems can hinder broader adoption and scalability because people don't want to have to be put on the spot to explain why did the AI make this particular decision this way. And the last is maintenance or model calibration. So AI models require extensive calibration to accurately reflect the complex realities of the changing manufacturing environments. And this process can be labor intensive and requires iterative adjustments that are more complex and require a different set of skills than for most static or traditional technologies. In just rule-based logic, as an example, you usually set it and forget it. You either get the rule right or wrong. But because machine learning gets better and better and better over time, with more and more data, you want to be constantly reevaluating it to fully take advantage of it and to improve it over time.
Okay, well, now that we covered the benefits and the challenges and the misconceptions, how do you convince stakeholders and leadership teams that investing in Industry 4.0 will bring a positive ROI, and what has worked in your experience?
Well, I'd have to say there are two ways to answer this. First, I fly all over the world speaking at public conferences and even privately for leadership teams at large companies. And the most effective way to, I'm going to say, convince is often to show them what happens if you don't do anything. Like when I do my standard Industry 4.0 presentation to companies, I typically tailor to their industry using public case studies from their peers as examples. That gets executives' attention, seeing what their competitors are doing. And in my opinion, even though we're still early in our Industry 4.0 journey as a society, there are enough companies that have been doing great things that it puts a lot of market pressure on everyone else. The World Economic Forum's Lighthouse program is just one great example of this. I believe as of last month, they're up to 172 public case studies. And they really kind of make you look at what the best of the best are doing out there. And so if you start to look at them as an example, you might start to wonder in 5 years what will happen to your company if you don't do something differently. And I'd have to say the second answer is I like to focus on future solving instead of problem solving. It is a concept I got from the book Autonomous Transformation by Brian Evergreen. So most companies and even most vendors always talk about problem solving. Few talk about future solving. So problem solving typically focuses on addressing current challenges and inefficiencies, leading to often incremental improvements within existing frameworks. But in contrast, future solving involves envisioning entirely new possibilities and pathways, kind of aiming to create transformative changes rather than just optimizing the status quo. So this forward-thinking approach not only solves existing issues, but also redefines what is possible. And that helps pave the way for radical innovation and progress.
All right. Well, I'm commit that to memory and try it out. See if it works in my conversations with some of the industrials. Jeff, thank you for sharing your insights with us. Typically, at the end of the episodes with Espresso 4.0, we do have a more light-hearted question for the audience to get to know you, who you are a little bit better. Although you are pretty open on LinkedIn as well, I have to say. But what I like to ask my guests is, if I called you at 2 p.m. on a Sunday, what would I be interrupting you in?
I would have to say normally you're going to catch me actually working on some LinkedIn posts. That's actually my youngest daughter's nap time. And so I try and take advantage of it. I get like usually 1 to 3 hours to work on. However, this last weekend and these upcoming future weekends, I've been working on a new Lego build during that time, which I hope to reveal here soon.
Can you tease us from a franchise of anything? Is it themed?
Oh, I don't want to give it away. This one, I'm pretty proud of it.
Fair enough. Well, we'll look forward to seeing it, and enjoy making it. Hope that we can grab a coffee sometime in the future. In the meantime, keep on keeping on and bring us good content about Industry 4.0. Have a good one, Jeff.
Thank you.